As GIS professionals, we often use GIS, or in this case, ArcGIS, to assimilate data. And we can perform ETL, or extract, transform, and load with ArcGIS Pro Append. And we can perform extract, load, and transform with ArcGIS Data Engineering. Let's talk about both of these tools, and we'll start with ArcGIS Pro Append. So we can use the Append tool to extract, transform, and load features and attributes. In ArcGIS Pro, that begins from the analysis ribbon and clicking on Tools. And then in the geoprocessing pane, you can search for and open up the Append tool. The other way, and the more common way that I access the Append tool in ArcGIS Pro, is from the catalog pane. I will go to the feature class to which I want to append features to, and simply right click on it in catalog and select load data. This approach also opens up that very same geoprocessing append tool. And then you need to configure the append tool. And it starts with your input data set, and that is the source features and or records for which you are loading into your target data set. Then you can add a SQL clause if you would like to restrict the features and or records of the input data set. Then you need to set the target data set. So in this case, my input data set is set to Texas State Park Boundaries shapefile. I'm going to restrict the values to prop type is equal to SP for state park, and I'm going to load those features and records into my TPWD_boundary geodatabase feature class. Now, many times when you're appending data, the schema or the field types don't match. And so if that's the case, you often need to use a field map to reconcile the field differences. So in the append tool, I set the field matching type to use the field map to reconcile field differences. And that opened up the field properties window, where I get a list of both the fields for the target data set and the fields for the input data set. So on the left are the fields for the target data set, and you can see I have a name field. And then on the right, I've said that the name field in the target data set is the same as the park name field in the input data set. So all the values in the park name field will load into the name field in the target data set. Last, and another great thing about the append tool, is that we can load or append the data directly into a subtype. So in this example right here, I've set an expression where prop type is equal to SP. And then if you go all the way down to the subtype, you can see I've loaded it to state park. So what I'm doing is selecting all the features and records where prop type is equal to SP in the Texas State Park boundaries, and loading those features and records into my target data set TPWD boundary and its subtype state park. Now, one thing I want to caution you about when using the append tool is it doesn't replace the data that's already in the target data set. It just appends it to it. So if, for example, you have a target data set that's empty and you load Texas State Parks boundaries into it, and there are 100 features in Texas State Park boundaries, and you load those 100 features into the target data set, but for some reason you can't see the results, and then you hit run again and you run it again, you're going to end up with 100 duplicate records and 100 coincident features in your TPWD_boundary or your target data set. So they're going to be really hard to track down because it's going to look like 100 features when there's actually 200 features there. So you need to be really conscious of the settings in the append tool, and then review your target data set when you're done to make sure that you accomplish what you set out to when performing extract, transform, and load. Now, while the append tool extracts and then transforms the data in the append tool and then loads it into your target data set, the data engineering tool extracts the data, loads it into your target feature class, and then you use data engineering to transform the features and attributes. So instead of ETL, it's ELT, extract, load, and transform. And so in ArcGIS Pro, in the contents pane, you select the target layer that you want to be working with. And then on the context sensitive data ribbon, under data engineering, click the data engineering button, and that opens up the data engineering view for that target layer. In this case, it's TPWD_boundary. The data engineering can be used for a lot of things. One thing is just to review your data schema or structure. You can see there's a visual list of all of the fields, including icons that show you the field type. You can very quickly open the attributes or update the symbology, and then you can add all of those fields to the statistics view so that you can actually see the statistics for the values for each of your field at a glance within that statistics view. So it can be really handy just to review your data. And then of course you can transform your data as well. In the example in the lower right-hand corner, I have added an acres field and calculated using data engineering. So on the data engineering ribbon, I clicked on construct and selected add field. And so I added an acres field to the TPWD_boundary table. That is a double precision or a decimal. And then again, on the data engineering ribbon, I clicked construct one more time and selected calculate geometry attributes. And in the calculate geometry attributes geoprocessing pane, I've set my input features to TPWD_boundary. My field that I'm going to calculate is my newly created field acres. I set the property to area and then the area unit to international acres along with a proper coordinate system. So when I run that, I have not only created a new acres field, but populated the acres field as well, all within the data engineering tool. So which tool should you use? The ETL append tool or the ELT data engineering tool? It's just going to depend on what you're trying to accomplish. And I would encourage you to work with both of those tools, learn them, because there will be times when you'll want to use the append tool and other times when you're going to want to use data engineering to assimilate data in your GIS. That wraps up our discussion on data assimilation. At this point, you should be able to explain how ETL or extract transform load is used to assimilate data, in which we extract data from a source database, transform the source format to a target format, and load the data in a target database. You should be able to describe how vector data is modeled in GIS as discrete features with precise shapes and boundaries, how raster data is modeled in GIS as continuous surface by dividing it into a regular grid of cells, and how triangulated data is modeled in a GIS to create a continuous and irregular network of triangles to represent terrain. In the associated project, you should create geodatabase subtypes and attribute domains, subtypes that allow you to subset the features and attribute domains that allow you to restrict the values in a field. And last, you should be able to use extract, transform, and load geoprocessing tools to assimilate data in GIS, like performing extract, transform, and load in ArcGIS Pro using the append tool, or performing extract, load, and transform in ArcGIS Pro using the data engineering tool.